Hello, this is Mr. Collier, and today we're talking about domain and range of a function. So it says that domain is the set of all permissible values that x may have, and the range is the set of all values that y may have. So when we take a look at this example, for the x values, for the domain, the function continues forever ever in this direction, so the x can be any number at all. So to write that in this notation, we can write x such that x is a real number. So we can write it like that. And the range, we can write it as, well, we see that y is the smallest value possible, or y equals -1 is the smallest value possible, and y can't be anything below -1. So we can write it like this: y such that y is greater than or equal to -1. The next example, okay, we have this function here, and the domain looks like domain could be anything. It's going off to -infinity and infinity, but it can't be -1 or +1. So that's like an asymptote right here. X cannot be equal to -1. So we can write x such that, so this is x such that x is not equal to 1. And for the y values, we have an asymptote here, and y cannot be equal to 0. So we can say y, or the set of all y, such that y is not equal to 0. Okay, the next function, we just have the function given in function notation, and it says f of x equals root x. Now, what values can x be? Well, x can be pretty much anything, but it cannot be a negative number. Okay, so if we put a negative number in here, you can't get the square root of a negative number, so we need to write the domain like this: x such that x is greater than or equal to 0. And for the y values, well, the smallest value that x can be is 0, and root 0 is 0, and then root 1 is 1, and so forth. So the y value here cannot be a negative number as well. So the range would be pretty much the same thing, except with a y, all y such that y is greater than or equal to 0. In the next example, we're finding domain and range using the graphing calculator. Okay, before we put this into the calculator, we will need to solve for y. So we're going to subtract x squared from both sides, and we get y equals 1 minus x squared. And over here we have to add 2, so we get y equals 2. And then we're going to sketch each graph. We're going to tell the domain and range for each function, and then sketch each graph. So domain and range. Okay, so let's get our graphing calculator ready. We're going to type in y equals -x squared plus 1, or 1 minus x squared. Same thing, and go to the, don't need graph there, okay. Go to the graph, and like most parabolas here, the x value can be anything, so we're going to write x such that x is a real number. And for the range, you can see that the parabola has a maximum at y equals 1, so we're going to write y such that y is a, oops, let me erase that. I'm going to write y such that y is less than or equal to 1. Okay, in the next example, we're going to, actually we should probably sketch that graph first. So it's downward facing parabola, and we know that y equals 1 right here, so let's graph that. Okay, just a rough sketch, and here we go. label the y and x axes, and that's about it. That's all you need. Okay, for the next one, we have y equals root 8 minus x. Y equals, let's delete all that. Okay, clear. So we have y equals square root of 8 minus x. And then graph it. Okay, there's what it looks like. So we can see that there's no x values beyond this point right here. Alright, and that will correspond to the value of 8 in this equation. So the x values have to be less than or equal to 8. Okay, so x such that x is less than or equal to 8 is the domain. And for the range, well, we can see that the smallest y value is 0, and then y can be anything above 0, so we're going to say y such that y is greater than or equal to 0. And let's make a sketch of the graph. Okay, it goes like this. And we can say there that, I guess we can say right there that that's the point x equals. Well, let's write it as coordinates. That's the point 8, 0. Up here that point was 0, 1. Okay, next we have the equation y equals 2. So we can graph that. And clear. Okay, y equals 2. Graph, and it's just a horizontal line at 2. So the x values can be anything, but the only y value possible is 2. So you can say x such that x is a real number. And for the range, y such that y equals 2. And let's sketch the graph. Here's x and y. And here's our function.